Okay, we're going to cover two topics, percent composition and empirical formula. Percent composition is just the percent by mass of each element in a compound. So the formula is just the total mass of an element divided by the molar mass of the compound. So let's do a couple examples. So what is the percent composition of H2O or water? So what you'll do is you'll determine the percent composition of hydrogen and the percent composition of oxygen. So the first thing we have to figure out is the molar mass of water. Molar mass of water is 18.02 grams per mole, right? And so therefore, in hydrogen, there are two hydrogens. Each hydrogen has a mass of 1.01, so it's 2.02. So this is the mass due to hydrogen. Divide that by the total mass, or the molar mass of water, and so you get 2.02 divided by 18.02, and you get 11.2%. Oxygen, there's only one oxygen. Mass is 16.00 grams. So 16 divided by 18.02 gives you 88.2%. Now, you could also say you don't necessarily have to solve for oxygen, and the reason is, if you think about it, this should be 88.8%. Once you figure out hydrogen's percent composition, you could figure out oxygen's percent composition. You could just subtract from 100, right? Because oxygen is the only other element, so you just subtract from 100. The percent should be the difference between 100 and 11.2%. Okay? So there's multiple ways of solving it. Okay, so find the percent chlorine and calcium chloride. So you got to remember calcium chloride is CaCl2. CaCl2, calcium. So let's first calculate the molar mass of calcium chloride. Calcium is 40.08 plus chlorine, which is 35.45 times 2. So the total is 110.98 grams per mole. So let's do chlorine. So chlorine, there are two. The mass of chlorine is 35.45 per chlorine. So therefore you get, this is be what, 70.9? 35.45 times 2. 70.9, divide that by the molar mass, and you get 63.9%. So that's due to chlorine. Okay? All right. So that's percent composition. Another one we're going to learn is empirical formula. So empirical formula is basically the lowest reduced formula. So for example, if you have C6H12O6, the empirical formula, the common factor that they have in common here is 6, right? So if I reduced it to the most simplest form, it would be CH2O. If I divided each of those subscripts by 6, right? And so H2O would be to H and O, right? Divide both subscripts by 2, and then H2O, there's nothing in common, so their molecular formula is the same as the empirical formula. So how do you calculate empirical formula using different in different problems? So we first take a look. We have experiment. In this experiment, we have calcium and oxygen. So I'm going to write calcium and oxygen. And we want to determine the empirical formula. So the amount of calcium is 2.514 grams. Oxygen is 1.004 grams. So the first thing you actually want to do is I'm going to write it up here. So number 1, you want to convert to moles. So to convert to moles, I'm going to divide by the molar mass of calcium, which is 40.08. Oxygen is divided by 16. So now I'm going to figure out the moles of calcium by dividing. So 2.514 divided by 40.08. So my answer is 0.06272 moles. So that's the moles of calcium. Then 1.004 divided by 16 is 0.06275 moles. So what I find is basically that the moles are now, so what that means is for every this many calciums, I have this many oxygen, moles of oxygen, right? And what I want you to see is that when we do an empirical formula, like for example HO, that means for every 1 mole of hydrogen, I have 1 mole of oxygen, right? That's what it means. And so what we're going to do is you divide by the smallest mole. The smallest mole amount. And the reason why we do this is we want to get whole numbers, right? When I write HO, it's not like I have H.25, O.25. I want to get it to the I want to get it to a whole number. So dividing by the smallest amount, I'm actually going to get it to a whole number. And so if you do this, this becomes 1, obviously, and this becomes very close. It's like 1.0004. So we actually just round it to 1. So that means for every 1 calcium mole of calcium, I have 1 mole of oxygen. So now our formula is going to be calcium 1 for every 1 I have oxygen. That's our empirical formula, our CaO. Okay? Sometimes there's the third step where if you don't get a whole number, you might have to multiply until you get a whole number. Okay, let's look at the second problem. Second problem is just a little different. The second problem is now percent composition. You want to calculate the empirical formula. The easiest way to do this is just assume that the whole sample is 100 grams. So if I have 100 grams and I have 40% of that, that means I have 40.05 grams, right? And so we always want to get it to grams first. So if you ever encounter percentages when you're calculating the empirical formula, change it to grams. The easiest way to change it to grams is just to multiply by 100 or just to make it out of 100. So sulfur is 40.05%, right? Which we're going to just make into 40.05 grams. Oxygen is 59.95%. We're just going to make that into 59.95 grams. Now it's exactly like we did the previous. So sulfur is 32.07 grams. I'm dividing by the molar mass, right? Oxygen is 16.00 grams. So now we're going to determine, we all want to figure out the moles of sulfur. So 1.248, I'll make that 9 moles. Then 59.95 divided by 16 gives me 3.747 moles. Now you want to divide by the smaller amount. So here 1.249 is smaller, so I'm going to divide that. So the ratio is 3.747 to 1.249, right? But that's not a whole number. So to get the whole number, we're going to divide. So this will be 1. This will be, what will it be? 3. So the ratio is 3 to 1. So this is SO3, right? That's the empirical formula. For every 1 S, there's 3 O's. A way to remember how to do this. So you first want to convert percents to grams, and then grams to moles, divide by small, and then multiply to whole. So it's a way to remember it. Here's homework. There's 5 problems for percent composition, and then 5 problems on empirical formula. You're looking. There will be a quiz on this on Friday.